Assalamualaikum to Dr. Nora Sinda. We are from Group K and we are going to present about the production of Lajak Huruf tablets. So my group consists of 4 members, that is me, Radina Zgauda binti Radin Bahrain, Siti Nurhaja binti Muhammad Shukri, Sujitra Nair anak lelaki Tewa Hari Nair, and Muhammad Zarfan Zuhair bin Azmi. So this presentation will consist of 4 parts. That is part A, that is will be presented by me, part B presented by Hajar, part C presented by Sujit, and part D presented by Zuhair. So for part A, I will describe and summarize the sample data of the assigned Lajak Laku tablet that is produced in December 2020, and I will try my best to present the observation effectively in numerical, tabular, and graphical forms. The first form that we can conclude from data key that is given is by sorting it using tabular form. The weight is ranged between 310 to 390 with interval of 10 milligrams. From here, we see that the mode for the weight is between 340 to 350 milligram with 65 frequency. As the relative density, the data is ranged from 84 to 92 with interval of 2%, and the mode for relative density is from 88 to 90 with 57 frequency. For the tensile strength, we can see that the mode is from 7 to 7.2 megapascals and the range is made between 6.8 to 7.6 with 0.2 megapascals interval. From the shift, most of the workers chosen the night shift because the frequency of shift is the highest, that is 70, while 62 shift in the evening and 68 shift in the morning. This table shows the numerical form of the given data K. This table consists of mean, standard deviation, and mode for each category, that is weight, relative density, tensile strength, and also mode for shift. So we can see the mean, standard deviation, and mode for weight, relative density, and tensile strength. This data is easily recorded by using pivot function in the Excel. So this table 3 is more focused on the shift in the morning, evening, and night. We found the mean, standard deviation, and mode for the weight, relative density, and tensile strength based on morning shift, evening shift, and night shift. The sample size for morning shift is 68, 62 for evening shift, and 70 for night shift. The third ways to present the data given is by using graphical form. Graphical form usually comes in the form of graphs such as bar chart, pie chart, and also a scatter chart. The graphical form of data K is shown as in figure 1. This bar chart shows the weight distribution of the pills. So the highest weight range for the pills is between 340 to 350 milligrams with frequency of 65 and followed by 350 to 360 milligrams with frequency of 53. This pie chart shows the production shift that is split into 3 shifts, that is morning, evening, and night. The highest production shift is during the night with 35%. So this scattered plot shows the hardness of tablet based on their tensile strength and relative density of the pills. It shows the relationship between tensile strength and relative density, where the higher the tensile strength, the higher the relative density of the pill. The trend line in the scatter graph showing a linear relationship that we can say that tensile strength has a strong effect or has a great correlation on the relative density of the strength. The data is making a straight line going from the origin to the high x-axis, that is relative density, and high y-axis, that is tensile strength, showed us that the variable has a positive correlation. This will be further explained in part D. That's all from me. Thank you.
Hi, so I will continue with next part, which is part B. Part B, we use goodness of fit test to determine weights of standard tablets produced by manufacturers. And we want to check whether the character they are normally distributed with mean 350 milligram and standard deviation of 14 milligram or not. So we make hypothesis for H0, the data follows normal distribution. For H1, the data does not follow the normal distribution. So this is our frequency table, which we find the frequency based on the range of weight. Next step, we find the probability of the tablets by using the normal distributed table in statistic book, and it resulted to probability equals to 1. So the next slide, we find the value of E. We find the value of E, which we find the value of E for each category, and the value of E should be more than 5. So for category 1, 2, and 9, it is less than they are less than 5. So I add 1. So we add 1 to we add 1 to category 3 and category 9 to 8. As we can see here, this is our result from the addition, and we have 6 category after the addition of category 1, 2 to category 3 and 9 to 8. So next is we find the test statistic. We calculate the test statistic and compare with the calculate statistic, follow the formula in the book by using the best alpha, which is 0.05. And as for P, it is the parameter that we need to estimate. But since we have given standard deviation and mean, P is equals to 0, since we don't have to estimate. And next, the conclusion is the test statistic is lesser than the statistic that we calculate follow the formula. So HO, our hypothesis accepted, and the data does follow the normal distribution. Okay, that's all from me. We can continue with part C.
Hello, my name is Nitin, and I will be presenting for Part C. So Part C, the task was we were required to present the required analysis and comment on whether there is any significant difference between the tablet weights from the different shifts. So first, we'll be looking at the summary of the data. We have the data separated into three groups, which are the three shifts: morning, evening, and night. Then we have the count, which is 62 from evening, 68 for morning, and 70 for night. Then we have other data also included, such as sum, average, and variance. So the one-way analysis of variance, also known as ANOVA test, was conducted to test whether there is any significant difference between tablet weights from the different shifts. The ANOVA test was conducted on Excel, or also in this case, we conducted it on Google Sheets using the extension of Excel Miner Analysis Toolpack. Next, we will look at the hypothesis. So for H null, we have mu1 is equal to mu2 is equal to mu3, which means all three groups have a similar mean, while the alternative hypothesis is that mu I doesn't equal to mu j for at least one I in j, where I does not equal j and alpha equals 0.05. Below that, we have the ANOVA table, which shows the source of variation, the sum squares, the degree of freedom, the mean squares, the f-test value, p-value, and f-critical. So the main value we'll be looking at here is the f-test value, which is known as f, which has a value of 1.429. Next, we have the p-value, which has 0.2419. And lastly, we have the f-critical, which is known as f-creep at 3.0417. Next, we'll look at the decision rule. So based on the decision rule, we have a graph here, which is a f distribution, and the shaded area refers to the alpha. So we will reject H null if f-test is greater than f-critical, or if the p-value is less than alpha, which is 0.05. Since the value of p, since the p-value was equal to 0.2419 is greater than alpha, which is 0.05, and the f-test, which is 1.429, is less than the f-critical, which is 3.140418, therefore we will fail to reject the H null. And as a conclusion, we can conclude that there is no significant difference between the tablet weights in milligram between the different shifts at 0.05 significance level. Thank you.
Assalamualaikum and hi, I'm Muhammad Azhar and I'll be presenting part D, which is the prediction of the tensile strength for such tablets, because studies have indicated that the tablet's tensile strength depends on the relative density regardless of the production shifts. So first, what we did was we obtained the regression statistics summary. So as you can see on your screen right now, we have a table of regression statistics. We have multiple R 0.8, R squared 0.7, adjusted R squared 0.7, standard error 0.1, and the observations are altogether 200. So how we obtain multiple R is we used this equation, and for multiple R and R squared, these are known as correlation coefficients. Also, the correlation coefficient significant must be more than 0.8 and less than negative 0.8. So from our table here, we can say that the correlation coefficient is partially significant. And the observation is also known as the sample size. Next, we obtained the ANOVA table, ANOVA testing. So with that, we can have the DF, which is the degree of freedom, SS, sum of squares, MF, means of squares, F is F-test, and significant F-test is, as you can see, that's 0. So the hypothesis statement is made to obtain the linear relationship between relative density and tensile strength. So here is the hypothesis statement applied for H null and H1. So we will reject H null if the significance of f is less than significance level. Since significance f is equal to 0, it is less than alpha equals to 0.05, therefore we reject H null. Thus, we can conclude that there is an existence of a linear relationship between tensile strength and relative density. Also, not to forget, we also obtain the estimate of unknown regression coefficient table, as you can see on the screen right now. And from the intercept and relative density, we are able to obtain an equation y bar equals to alpha bar plus beta bar times x. And the t-stat in this table represents the value of t-test for alpha bar and beta bar. This equation up here can be used in our graph plotted in the next slide. So this is the graph we obtained for our line fit plot. So the blue dot is the tensile strength. The yellow line is the trend line for tensile strength, R squared. So as you can see, the blue dot doesn't always fall on the yellow dot. Instead, some may be above, some may be below the yellow line. This shows how good the line fits the observed data points. The term residuals in this case are the amount of blue dot above the yellow line and the amount of blue dot below the yellow line. And if you were to calculate the residuals, you'll see that they are the same amount. The amount of blue dot above and the amount of blue dot below the yellow line is the same. This shows that the line fits the observed data points. From the graph plotted, we can obtain the data of normal distribution test. So the straight line in figure 4.4 just now represents the fitted regression line. The Pearson correlation coefficient of R is 0.8. Thus, since it is close to value 1, it indicates that there is a strong positive linear relationship between relative density and tensile strength. Therefore, we have the target fitted simple linear regression equation as below. And as you can see at the table right now, all the values of tensile strength for relative density of 68%, 74.3%, and 18.1% are embedded because they are out of range. So the value range of relative density based on the graph plotted is 82.1% to 92.9%. And that is all from me. Thank you.